Okay, so we're going to look at the first part of the Introduction to Fractions activity. It starts by telling us about a fraction, which is the numerator over the denominator. The numerator tells us the number of equal-sized parts selected from the whole, so what they're describing. The denominator tells us the number of equal-sized parts required to make one whole. So let's say I'm talking about eating pizza. There's 6 slices of pizza. 6 slices would make the whole. If I ate 1 slice, I'd be eating 1/6 of the pizza. Alright, moving on to shapes. I've got hexagon, trapezoid, rhombus, triangle, and I've got my little shapes here to work with. We're going to assume the hexagon is one whole, and they want to know what fractional part is represented by one trapezoid. So remember, I'm kind of thinking to myself, the number of parts to make one whole is going to be my denominator. So let's start by trying to fit our trapezoids into our hexagon. So how many parts does it take to make a whole when I'm using the trapezoid? Okay, so I've got 2 parts needed to make the whole. And what are they describing in the problem? Well, what fractional part is represented by one trapezoid? That's going to go on the top of my fraction. So I have 1/2. And that makes sense just if you look at it, right? You can see that the red is 1/2 of the yellow. Okay. Moving on to number 2. What fractional part is represented by one rhombus? And so the rhombus is this blue one. So I'm going to see, well, how many parts does it take to make the whole when I'm using the rhombus shape? Looks like I'm going to need 3 of those to make it. So I know I'm going to have 3 in the denominator, and so one rhombus is going to go on the top, so 1/3. And again, that kind of makes sense if you look at it. The blue is 1/3 of the yellow. What fractional part is represented by one triangle? So again, I'm going to figure out, well, how many parts does it take to make the whole? That's going to be my denominator. Let's just start filling those in. It's going to take a bunch of these triangles. So let's go ahead and piece them in here. In fact, it looks like I maybe am one short, but you can visualize it, right? If I had a 6th one right there, I'd have 1, 2, 3, 4, 5, 6 triangles as my denominator, and so one triangle goes on top. So 1/6 of the hexagon. Okay, now thinking about 12 rhombi, so that was this shape. How many hexagons is that going to make? Well, if I put 3 of them together, that's going to make 1. So if you imagine 3 rhombi is going to equal 1 hexagon. And I have 12 of these that I'm doing. So I'm going to have a group of 3, another group of 3, another group of 3, that's 9, another group of 3. So 3, 6, 9, 12. So imagine these 12 rhombi here, and so that's going to make 1, 2, 3, 4 hexagons. Okay. Which shapes could you use to represent the fraction 2/3? So it looks like with a hexagon to make 2/3, well, 1/3, we knew that was the rhombus, right? So if I put 2 of them together, that's going to give me 2/3. So you'd want 2 rhombi, or 2 of the rhombus shapes. Alright, moving on to the next page. Now I've got 2 hexagons being one whole. Okay, so I'm going to put those together to make my one whole. What fractional part is represented by one trapezoid? Okay, so remember our denominator, we're still thinking how many of these trapezoids would it take to fit with this whole? So how many is it going to take? Well, I'd have 1, 2, and then I'd have to do another 1, 2 there as well. So it's going to be a total of 4 trapezoids to cover up the 4 trapezoids to make the 2 hexagons. So a total of 4, and then we've got 1 trapezoid that they're describing, so it'd be 1/4. Again, you can kind of just look and see, okay, that takes up 1/4 of this shape. what fractional part is represented by one rhombus? So similarly, I'm going to think, well, how many of these would it take to cover up my whole in this case? So it would take 3 here, and then 3 more here, so that's a total of 6. So I have 1 out of 6. One triangle, so counting them up, I'm not going to put them all here, but you remember there were 6 here, and then I'd have another 6 here, so 6 plus 6 would give me 12 total needed to cover it. So 1/12 would be one triangle. Alright, which fraction is represented by 3 trapezoids? So we've got 2 trapezoids making the whole, so that would be at least 1, right? But now if I just have 1 extra trapezoid left, I don't have another trapezoid shape, but if you kind of imagine putting 1 trapezoid on top of this, I'd have 1 out of 2 covered, so I'd have 1/2 made up by that 3rd trapezoid. So this one whole would be 2 trapezoids. Oh, you know what? Sorry, I'm thinking of hexagons for a second. Let's back up for a moment. I was thinking they were talking about 3 hexagons. Oh, trapezoids. That's actually a little bit easier. Delete that. Okay, 3 trapezoids. That's these red ones. Oh, I also do not have enough. But if we put 2 here, and then we put 1 over here, I'd have 1, 2, 3. You can kind of picture it covering it up. I'd have 3 covering up out of 4, so it'd be 3/4. Alright, that's actually a much simpler problem than 3 hexagons. That would be a mixed number, 1 1/2. Okay, and that's it for the shapes.